All right, it's time to make things just a little bit more complicated. We're going to be solving problems with two different variables. So I'm going to start a new header cell here, a new cell, and call it problems with two variables. And I'll start with a clear CLC. This is a good practice to get into when you're turning in challenge problems because it makes sure that the workspace is nice and tidy and gets rid of any stray variables that might exist. Notice I typed it into the script. I'm not just putting it in the command window to clear it manually. I actually want it to be part of the script that gets run when whoever, like my instructor, opens up this file and runs it. So when the first time that we run this section, it'll clear out all of our variables. All right, we have seen, let's see, we have seen we can multiply scalars together. No problem. We can multiply a matrix by a scalar, whether it's one-dimensional or two-dimensional, it's still a matrix. That's fine. We use dot star to multiply two matrices element by element for element by element multiplication. Sure. So for example, if we have x equals 1.5 and y is the same as x, then we can do x dot star y. Let's run this and see if we get an error message. I always like to see if I get an error message. Remember how I said it would clear up all of our workspace? It did. Awesome. Notice x and y are the same size. This works because x and y are the same size. If we made them matrices, like 1 to 5, whoops, there we go. This will still work. I'm going to run this section again. I still get a perfectly reasonable answer because they were both 1 by 5. And this dot star means element by element multiplication. Okay. Now let's just change one of them. Let's change just the x to be 1 to 3. What if we said, I want to take all the numbers from 1 to 5, that's currently stored in y, and all the numbers from 1 to 3 and multiply them all by each other. Now if I do x dot star y, I get an error because the matrix dimensions must agree. In order to use dot star, we cannot have different size matrices. So let's think about this for a minute. Let's pause for a minute and say, what is it we're actually trying to do? I want to take all the numbers in x, and for each of them, multiply by all the numbers in y. This is kind of like building a multiplication table where you have x across the top and y down the side, and then I want to fill in the whole grid. We can do that with MATLAB. This is a special kind of command. So I'm going to comment out this. I don't want the error, suppress that. I've got my x and y that I want to use, and so let's say, how do we use this new command called Meshgrid in order to multiply all the elements of x times all the elements of y? That's what I'd like to do. I've added a note here, what we're trying to do, and I will say, to create this multiplication table, use Meshgrid. It's all one word, that's the command we're going to use. The tricky part about Meshgrid is a lot like min and max when you are saving with two outputs. You have to have two outputs in order to have MATLAB store both of the things that you need, both of the items that you need. Kind of like size. The size of a matrix reports both the number of rows and the number of columns. So there's two outputs, and that's what has to happen in order for Meshgrid to work. So let me make a note of that too. You must store the result of Meshgrid in two outputs. This is the part that everybody gets tripped up on. So let's make up new names for two new outputs. We didn't have these before, they didn't exist before, I'm making them up right now. I will call them new x, comma, new y. They're brand new. These are just the names of new variables I'm declaring in order to store the result of the output. So I use an equal sign to say, hey, I'm going to be putting something new in here, and it's the result of Meshgrid. Meshgrid XY. It looks so simple, but what is it doing? What is it doing? What it's doing is creating a whole new set of matrices that are the same size. So my new X and new Y that I just am about to run and create using this command right here will be the same size. And that's why we need this. So let's run it. Run section. Now take a look. I'm going to scroll up a little bit. New X. This has all the elements of X repeated over and over again. Why? So that it has the right number of rows. New X is a whole new matrix that just came into existence. It has the Y values in columns, 1 through 5, 1 through 5, 1 through 5, repeated 3 times. Why 3 times? Because that's how many elements were in X. So Meshgrid has created the appropriate size variables, the appropriate size matrices that we can now multiply together. You can't forget this step. Oops, times. Dot star. I want element by element multiplication now. So you can't forget this step because all Meshgrid did was make the right size matrices. It didn't multiply anything together. Now we will take the new X and new Y, multiply them together, and save it as a new matrix called A. Okay, so let's run that section. And here's my multiplication table with 1 through 5 and 1 through 3 on the column and row. And then I have this grid of all possible combinations of multiplications in there. So that's what Meshgrid does. It's a little tricky to use, but let me write a note about it. What Meshgrid did was create 2 new matrices of the appropriate size so that now they can be element multiplied. Element multiplied. All right. This gives us the multiplication table we wanted. All right. You'll get more practice with Meshgrid as we go on, but that is all for now. I'll see you next time.